Hello again and welcome to our second video for DMA 30 Section 1, Rates and Ratios. Last video we talked about ratios and today we're going to talk about some rates. To review from last time, we covered all the different definitions for ratios and different ways to define them. We looked at equivalent ratios and then simplifying ratios. And then lastly, converting units so we can write a ratio, because we know with a ratio all the units have to be the same. This time we're going to discuss rates, so we'll talk about a definition for rates and how to write them, unit rates, and then unit prices. So we define a rate as the quotient of two quantities that have different units. Remember, with ratios the units were always the same. It was feet over feet or minutes over minutes. With rates we're going to be comparing quantities with different units. So it might be miles per hour or dollars per pound. Okay, we'll have different units for each of the numbers that we're comparing. So for an example, the fastest growing flowering plant on record grew 12 feet in 14 days. Write the rate of growth as a fraction in simplest form. So let's start out with the fraction, 12 feet over 14 days. The number that we read first goes on top. The number that's second goes on bottom. Alright, and we notice that 12 and 14 have a common factor of 2, so we'll go ahead and divide that out. We'll divide the top by 2, and then divide the bottom by 2, and we'll get 6 feet over 7 days. And that's completely simplified. 6 and 7 don't have any common factors, so this rate is in simplest form. Now, as far as the units go, we can leave them in the fraction, but most of the time we'll see them written like this. We'll see the rate of 6/7, and we might write the unit as feet per days with a forward slash like that. Okay. So again, simplest form, 6/7 feet per day. Now let's look at unit rates. That rate that we looked at earlier, 6/7 feet per day, is kind of an awkward rate to imagine. So that's where unit rates come into play. A unit rate is a rate that has a denominator of 1, or we say that we write it as a whole number or decimal number. To write a rate as a unit rate, we're just going to divide the numerator by the denominator. So in this example here, there are 204 calories in an 18-ounce can of cranberry juice. Let's write this rate as a unit rate. So if we're going to write this as a fraction, we might say 204 calories per 12 ounces. Okay. But that's kind of an awkward rate to envision, to imagine, so we're going to write this as a unit rate. Just like in the definition, we're going to divide the numerator, the number on top, by the denominator. Alright, 12 won't go into 2, but it'll go into 20 one time. 12 times 1 is 12. We'll subtract and get 8, and then bring down the 4. And then 12 will go into 84 7 times. 7 times 12 is 84. We subtract and get a remainder of 0. So we would write this unit rate as 17 calories per ounce. Okay, so nothing on the denominator. We say the denominator is 1 or a whole number. If it didn't divide out even, we would continue to divide until we get a decimal, because unit rates will never have a remainder or a mixed number portion. We always want a denominator of 1. Let's look at another example of unit rates. Here, Joan earns $436 per 40-hour work week managing a dress shop. Write this rate as a unit rate. Okay, so we know we're going to divide the first number by the second number, but what else tells us to divide? The word per. That's a key word that means division in math problems. So let's do the division here. 436, the first number, divided by 40. Okay, 40 won't go into 4, but it goes into 43 once. 40 times 1 is 40. We subtract and get 3, and bring down that 6. Now, 40 won't go into 36, so we have to remember to put that 0 placeholder there. Okay, but since this is a unit rate, we're not going to have a remainder to express as a mixed number or anything like that. Let's add some zeros, okay, and bring those down. Now we have 40 going into 360. Let's not forget to put that decimal, bring that decimal up. We added the decimal, added a 0, but we have to bring it up to the quotient 2. 40 will go into 360 9 times. 40 times 9 is 360. We subtract and we get a remainder of 0, so we don't have to bring down any extra zeros. But since this is a unit rate that we're going to express in dollar amounts, let's carry it out to 2 decimal places. So we have both, we go to the hundreds place since we're representing cents here. We would write this as $10.90 per day. Now let's talk about unit prices. A unit price is a rate of how much was paid for one unit or one item, and it's the quotient of the price to the total number of units. So we have a nice little formula here. The unit price is the total price divided by the number of units. So if you look closely the next time you're in a grocery store and you look at the price tags on the aisle, a lot of grocery stores will post the unit price, usually in dollars per ounce or dollars per gram. So pay attention to the next time you're in a grocery store. When you're shopping around, maybe in the soda aisle, look at the price per for a 2 liter of soda versus a 12-pack of soda or a 6-pack of soda, and see which is the best unit price. The smaller the unit price is going to be the better deal that you're getting. Let's do a unit price example. A fast food restaurant sells a 12-ounce cola for 72 cents and a 16-ounce cola for 99 cents. Which is the better buy? Alright, so to do this, we're going to divide, we want the price, price per ounce. Okay, so we're going to do the cost and then divide by the ounces. So for our first example, we have 72 cents divided by 12. Okay, let's bring that decimal up so we don't forget to. 12 won't go into 7, so let's put that 0 placeholder. But 12 will go into 72 6 times. Okay, so 6 times 12 is 72. We subtract and we get 0. So for our first example, the unit price is 6 cents per ounce. In the second example, we have a price of 99 cents divided by 16 ounces. Alright, we'll bring up that decimal. 12 won't go, 16 won't go into 9, so we'll put the 0 placeholder there. But 16 will go into 99. How many times will it go into 99? Well, let's see. Let's try 16 times 6. 16 times 6. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. So it'll go in there 6 times. That's 96. We'll subtract and we'll get 3. Okay. Add a 0 to keep going since we still have a remainder. Alright, 16 will go into 30 once. That's 16. We'll subtract and we'll get 14 here. And we can keep going, but we can already see that it's just a little bit more per ounce because we have this extra thousandths of a cent for the second price here. So actually here the 12 ounce is going to be cheaper. Again, this is going to terminate after the hundredths place, but since this has some more division going on after the hundredths place, starting the thousandths place, that means it's just a little bit bigger. So the better buy is going to be the 12-ounce soda here. Okay, so we're done. To review for section 3.1, we talked about ratios, their definitions, and how to write them. Equivalent ratios, how to simplify a ratio and write it in lowest terms, and then converting units so they're the same, so we can write a ratio. And then to finish up the discussion, in this video we talked about rates. We defined the rates and showed how to write them, and then we looked at unit rates and unit prices. Stay tuned for next time where we discuss section 3.2.